let's look at this question. Which one of the following vectors is orthogonal to the line xyz given by this thing? First thing here to see is that this line is given in 2-point format or form equation. So what is it? It is x equal to 1 minus t times p plus t q. Well, where p and q are 2 points on the line. So when you have 2-point form, you can find parallel vector of a parallel vector for the line, which would be a equivalent vector to PQ. So in this case, the parallel vector, we usually use V for that, is P equivalent vector to directed line segment PQ. Well, in this case, you see P is this, Q is that. So we have a first component of endpoint minus the first component of starting point. And you do repeat it for the second component and the third component. So we get 2, -1, and -1. So now I have a vector which is parallel to the line. So the line is any line you have. And we have a vector v which is parallel to that. Any vector which is perpendicular to that line will be perpendicular to V. So this being said, you have to check which one of these vectors is or are orthogonal to the given vector. So I will do check one by one. So for A, 2, -1, -1 dot 0, 3, 3. We know orthogonality, we always check by dot product. This will be 0, negative plus 0 plus -3, and then plus -3, which is -6. It is not 0, so the first one cannot be the right answer. B, 2, -1, -1 dot 2, -1, -1. Well, the vector cannot be orthogonal to itself because this is always a number not equal to 0. Well, non-zero vector cannot be orthogonal to itself. 2, -1, -1 dot -3, 4, 5. This will be -6 -4 -5. This is a huge negative number. It is not 0, so this will go away. D, 2, -1, -1 dot -2, 1, 2. So this will give 1, -4 -1 -2. Yes, and that is definitely not negative. Okay, let's see the last one. 2, -1, -1 dot 3, 2, 4. This is 6 -2 -4. That is 0. So this was not 0. So this vector has dot product to 2, -1, -1 equal to 0. So that means that is the vector which is orthogonal to the parallel vector. In particular, it is orthogonal to the line.